Hey everyone, and welcome back to the channel. Today we're diving deep into our planet's incredible and sometimes explosive power. We all know about earthquakes, right? The ground shakes, buildings sway. But what if I told you that sometimes these geological shifts can lead to something straight out of a sci-fi movie? I'm talking about massive steam explosions. So how does this even happen? It all starts deep beneath our feet in the Earth's crust. Picture this. Huge tectonic plates, continent-sized slabs of rock, are constantly on the move. They grind against each other, pull apart, or one slides under another. This movement is what we call a geological shift. Now, these shifts don't just happen in a vacuum. The Earth's crust is full of fractures, faults, and porous rock layers. And what often fills these spaces? Water. We're talking about vast underground reservoirs known as aquifers, and groundwater seeping through cracks for millennia. Here's where it gets interesting. The deeper you go into the Earth, the hotter it gets. This is called the geothermal gradient. In some areas, especially near volcanic zones or deep fault lines, this heat is intense. We're talking about temperatures high enough to boil water many times over. So you have water trapped underground and the surrounding rock is getting hotter and hotter. But because this water is under immense pressure from the tons of rock above it, it can't just boil and turn into steam like it would in your kettle at home. Instead, it becomes what we call superheated water. It's still a liquid, but it's way above its normal boiling point of 100 degrees Celsius or 212 Fahrenheit. It's a liquid with a temper, holding an enormous amount of stored energy. Now, let's bring back our geological shift. An earthquake happens. The ground suddenly fractures or a fault slips. What does that do? It instantly releases the pressure. Think of it like shaking up a can of soda and then popping the tab. All that pressure is gone in a fraction of a second. And what happens to that superheated water when the pressure vanishes? Boom! It flashes into steam instantaneously. This process is called a flash vaporization, and it's incredibly violent. When water turns to steam, it expands in volume by about 1,700 times. Imagine that happening to a massive underground reservoir all at once. The result is a phreatic eruption, or what we more commonly call a steam explosion. This isn't a volcanic eruption with lava and ash from magma. This is pure, raw power from superheated water exploding. The force can be catastrophic, powerful enough to blast rock, soil, and anything else on the surface hundreds or even thousands of feet into the air, creating a massive crater. These steam-driven explosions can happen with very little warning. Unlike volcanic eruptions, which are often preceded by specific types of seismic activity or ground swelling as magma moves, phreatic eruptions can be much more unpredictable. The trigger is often a standard tectonic earthquake, which can happen in many different regions. So where do we see this phenomenon? One of the most famous examples is the 1886 Tarawera eruption in New Zealand. A series of earthquakes tore open a 17-kilometer-long fissure in the ground. This fissure sliced through a hydrothermal system, causing a massive chain reaction of steam explosions that reshaped the entire landscape. Yellowstone National Park is another prime example. It's sitting on top of a massive hydrothermal system, and its geysers and hot springs are surface-level proof of the superheated water just below. While Old Faithful is a gentle, predictable release of this pressure, a significant earthquake in the right spot could theoretically trigger a much larger, more violent steam-driven event. Geologists monitor these areas very closely for this exact reason. The connection between earthquakes and steam explosions is a two-way street. Not only can an earthquake trigger a steam explosion, but the process of water flashing to steam can also cause its own seismic tremors. The rapid expansion and violent release of energy generate their own shock waves, which can feel like a small earthquake to anyone nearby. It's a complex and fascinating feedback loop. This brings us to a crucial point about understanding natural hazards. It's not just about a single event, like an earthquake. It's about how different geological systems are interconnected. An earthquake in a coastal region might trigger a tsunami. An earthquake in a mountainous region can cause landslides, and an earthquake in a hydrothermally active area can lead to powerful steam explosions. Studying these connections is vital for hazard assessment and public safety. Scientists use a range of tools to understand these risks, They use seismometers to monitor ground shaking, GPS stations to track ground deformation, and gas sensors to check for changes in what's being released from the ground. By putting all this data together, they can build a more complete picture of what's happening beneath our feet. For example, if they see an increase in small earthquakes in an area with a known underground water source and high geothermal heat, that could be a red flag. It might indicate that pressure is building, or that the rock is becoming less stable, increasing the potential for a sudden pressure release and a subsequent steam explosion. Understanding this science isn't about being scared of the ground we walk on. It's about appreciating the immense dynamic forces that have shaped our planet and continue to do so every single day. It reminds us that Earth is a living, breathing entity in its own way. The very same heat that can cause these explosions is also harnessed for geothermal energy, a clean and sustainable power source. So the next time you hear about an earthquake, take a moment to think about the complex chain of events it could set in motion. It's a powerful reminder that geology is anything but boring. It's a story of pressure, heat, and sudden dramatic change written in the very rock beneath us. Thank you so much for joining me on this deep dive today. I hope you found it as fascinating as I do. If you enjoyed this video and learned something new, please give it a thumbs up and consider subscribing to the channel for more science content. Don't forget to hit that notification bell so you won't miss our next adventure. Let me know in the comments if you have any questions or what geological topic you'd like me to cover next. Stay curious, and I'll see you in the next video.